So, question number 60 is on your screen. Roasting of sulphide gives a gas X as a byproduct. This is a colorless gas with choking smell of burnt sulphur and causes great damage to respiratory organs as a result of acid rain. Its aqueous solution is acidic, act as a reducing agent, and its acidic has never been isolated. The gas is. So, basically this question is come from your metallurgy chapter of your class 12 NCERT. So, now we are moving to the solution part. Now, they are giving us roasting, and roasting basically roasting of sulphides. So, here this sulphide, that is MS, I am writing as MS, it is react with oxygen and it will give your that metal oxide plus your sulfur dioxide. So, this is the reaction. Okay. Now, this is a colorless gas. So, among this only your colorless gas your sulfur dioxide with choking smell of burnt sulfur. Okay. Sulfur, they are mentioning here already sulfur. So, if they are mentioning sulfur here, so remaining part you can neglect it out. So, if you see in the option, only option 1 also having sulfur, option 2 also having this sulfur, and option 4 also having this sulfur. So, you can remove this part carbon dioxide. So, this is not possible. Cause a great damage of the respiratory organ as a result of acid rain. Its aqueous solution is acidic, act as a reducing agent, and its acid has never been isolated. So, if you see the roasting process of sulphide, this is the reaction, and during roasting we are obtaining this sulfur dioxide as the gas. So, if you see in your option number 2 only having this sulfur dioxide. So, option number 2 is the correct answer of your question number 60. So, these chapters come from your metallurgy, okay, metallurgy of your class 12 NCERT. Okay. It is given as general principle on your NCERT. So, option number 2 is the correct answer of your question number 60. So, now we are moving to the another question, that is question number 61. So, question number 61 is on your screen. Which is the strongest acid in the following? So, now we are moving to the solution part. So, for this they asked about the strongest acid, okay, and you always remember these all are given as oxoacid form. So, strongest acid here is directly proportional to the oxidation state, okay. This you have to remember, who having the higher oxidation state, they are the strongest acid. Now, if you find out the oxidation state of sulfur, so it will be plus 2 plus x minus 4 into 2, that is will be 8 equal to 0. So, x is equal to, that is 2 into 2 minus 8, that is minus 6, and it will be plus. So, here sulfur having this plus 6 oxidation state. Now, for this chlorine again 1 plus 1 minus x, 3 into minus 2, this will be minus 6, that is minus 6. So, x here end up with equal to 0, and here x value it will be end up with 1 place, that is minus 5, and minus 5 is will be end up with plus 5. So, here this chlorine value it will be plus 5. Now, for this one again I am putting as x here, it is 1 plus 4 into minus 2, that is minus 8 is equal to 0. Here also x is end up with plus 7. So, here chlorine value is chlorine having the plus 7 oxidation state. Now, for this one again it will be s plus 2 minus 3 into minus 2, that is minus 6 is equal to 0. Here x it will be end up with plus 4. Okay. So, here it will be plus 4. Now, I already mentioned who having the strongest acids, who have the highest oxidation state. Now, among the following, if you see the option number 3 having this plus 7 oxidation state. So, option number 3 is the correct answer of your question number 61 by using this trick. Okay. This trick is useful for all the oxoacid compounds. So, for if they ask you any questions regarding oxoacid, who is the strong acid or strong base, you just find out the strongest acid is directly proportional to oxidation state, means you directly find out the oxidation state of that oxoacids. So, now we are moving to the another question, that is question number 62. So, question number 62 is on your screen. Which of the following is paramagnetic? So, this question is come from your chemical bonding chapter of your class 11 NCERT. So, now we are moving to the solution part. So, for paramagnetic we need to find out the unpaired electrons, right, unpaired electrons. Who having this unpaired electrons, that compound or that element is paramagnetic in nature. Now, first you have to count out the total electron count, okay, total electron count. How it will be, find it out? For carbon it will be 6, for oxygen it will be 8. So, 6 plus 8, 6, 6, 12, 13, 14, okay. For it will be 14. For O2 minus 8 plus 8 plus 1, that is your 16 plus 1, that is will be 17. Night for this cyanide it will be 6 plus your nitrogen it will be 7 plus 1, that will be 14. Now, for NO plus, for nitrogen it will be 7, for oxygen it will be 6, and for this one minus 1. So, it will be here as 13 minus, that is will be 12, right. 7 plus 6, 7 plus 6 it will be 13, 13 because of this, sorry. So, for nitrogen it will be 7, for oxygen it will be 8, not 6, okay, 6 for carbon, sorry for that mistake. For plus symbol it will be there, so 1 electron will be less. So, 7 plus 8 it will be 15, 15 minus 1 it will be 14, so 14. Now, we know there is a formula I already mentioned, the sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then another one is your sigma 2pz and pi 2px equal to pi 2py, pi star 2px equal to pi star 2py and sigma star 2pz. This is particularly useful when your total electron count, if it will be greater than 14. Now, another one we are obtaining sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, then pi 2px equal to pi 2py, sigma 2pz, pi star 2px equal to pi star 2py, sigma star 2pz. This is basically used for when total electron count it will be less than or equal to 14. Now, if you see for this one, for CO first option, how many electron is there? 14, means 2, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, then 13, 14. See here no unpaired electrons will be not there. It will follow this part, right. Here see for this option number 1 no unpaired electrons. So, this is not the option because we require unpaired electrons. Now, for O2 minus, if you see O2 minus it will be 17. So, it will follow the first order. How many electrons are 17? So, 2, 2 plus 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, then 15, 16, 17. Okay. So, it having one unpaired electron, right. So, 2 plus 2 that is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. So, this is the it having one unpaired electrons. Now, if you see the 14, every 14 does not have unpaired electrons, only in your option number 2, that is O2 minus, having this one unpaired electrons, right. This is unpaired electrons, and as a result unpaired electrons is present. So, this O2 minus is act as a paramagnetic in nature. So, option number 2 is the correct answer of your question number 62. So, now we are moving to the another question, that is question number 63. So, question number 63 is on your screen. Which of the following structure is similar to graphite? Okay. So, now we are moving to the solution part. Now, if you see, they asked about the structure of graphite, and if you see option, that is boron nitride, this is basically called as inorganic graphite. Okay. Inorganic graphite. So, option number 1 is the correct answer of your question number 63. So, now we are moving to the another question, that is question number 64. So, question number 64 is on your screen. The basic structural unit of silicate is. So, now we are moving to the solution part. So, it is a very easy question. So, they ask about the basic structural unit for silicates. So, silicate structures is look like this: SiO minus, O minus, O minus, O minus. So, if I am writing this one SiO4 4 minus. Okay. So, this is the structural unit of silicate. Now, if you see your option number 2, that is SiO4 4 minus is the correct answer of your question number 64. So, now we are moving to the another question, that is question number 65. So, question number 65 is on your screen. Reaction by which benzaldehyde cannot be prepared. So, now we are moving to the solution part. So, if you see, they ask about reaction by which benzaldehyde cannot be prepared. Okay. So, if you see, this question is come from your aldehyde alcohol part of your aldehyde ketone and carboxylic part from your class 12 NCERT. Okay. Now, if you see among the 4 option, that is zinc, Ag and concentrated HCl, this reagent useful for aldehyde and ketone. Okay. This reactant or this reagents cannot use for COOH. Okay, this is cannot use for your carboxylic acid group. So, your option number 4 is the correct answer of your question number 65. So, now we are moving to the another question, that is question number 66. So, question number 66 is on your screen. Which of the following does not give oxygen on heating? So, now we are moving to the solution part. So, if you see the among 4 option, that is ammonium dichromate, this is ammonium dichromate, when it will be heat, it will form like. So, if you see this one ammonium dichromate, when it will be heated, it will give N2 plus Cr2O3 plus H2O. It will not give any oxygen, do not give any oxygen. Now, if you see the above reactants, when they are heating, they will give you the oxygen. Now, in question they ask about does not give. So, first mark it, does not give oxygen on heating, and your option number 4, that is ammonium dichromate, is the correct answer, which do not give oxygen on heating, and this is the answer of your question number 66. So, now we are moving to the another question, that is question number 67. So, question number 67 is on your screen. So, which of the following lanthanide ions is diamagnetic? So, this question is come from your D and F block elements of your class 12 NCERT. So, it is a very easy answer. So, now we are moving to the solution part. If you see the ytterbium, like ytterbium, the formula is the not formula, that is electronic configuration is equal to Xenon 4F14 6D0 5S2. Now, ytterbium 2 plus, if you see here, it will be give you Xenon 4F14, because 2 is leave it from this 5s orbital. So, here we do not have any unpaired electrons. Okay. So, no unpaired electron. So, if no unpaired electron, so this is a diamagnetic. So, if you see your option number 4, that is ytterbium 2 plus is the correct answer of your question number 67. For these types of configuration, you should just know the electronic configuration. Okay. So, now we are moving to the another question, that is question number 68. So, question number 68 is on your screen. Identify the correct order of solubility in aqueous medium. So, this question is come from again D and F block elements of your class 12 NCERT. So, now we are moving to the solution part. Now, here they are giving this all sulfides. Okay. Here see, if you see all the sulfides. Now, always remember the group 1 elements. Okay, group 1 elements, sulfides are highly soluble. So, if you see among the options, your option number 1, it is not possible because it will be given in the least soluble. Here also it will not given a high soluble. So, option number 1 and option number 2 we can eliminate out. Now, we have to left it out only 2 options, option number 3 and option number 4, where both group 1 elements, because sodium will be coming in group 1 sulfide. So, group 1 sulfide is highly soluble. Now, among this, that is the D blocks elements, for zinc sulfide and copper sulfide, zinc sulfide solubility will be higher than your copper sulfide. Okay. First point this one, second point is this one. Okay. Now, if you see here, your option number 3, copper sulfide will be given first, then zinc sulfide, which is not possible, because here zinc sulfide will be highly soluble than your copper sulfide. So, your option number 4 is the correct answer of your question number 68. So, we are now moving to the another question, that is question number 69. So, question number 69 is on your screen. XeF2 is isostructural waste. So, this question is come from your chemical bonding chapter of your class 11 NCERT. So, now move on to the solution part. Okay. So, first let us find out the hybridization of XeF2, that is xenon difluoride. So, xenon having 8 valence electron and it will be bonded with fluorine. So, now how to find out the hybridization? See, number of atom attached, that is 2 number of atom attached plus number of lone pairs present 1, 2 and 3, it will be coming as 5. So, 1 is goes to S, 3 will goes to here. Now, how many left it out? 3 plus 1 4, 1 more is left, that is D. So, sp3d is the hybridization of xenon difluoride. Now, what is the shape of it? Xenon, these are the lone pairs and fluorine will be go here. So, this is nothing but this is your linear shape structure, okay, linear shape. Now, if you see among these 4 options, if you see ICl2, the structure is similar to this, okay. So, this is also a linear in shape. So, option number 2 is the correct answer of your question number 69. Now, we are moving to the next question, that is question number 70. So, question number 70 is on your screen. An excess of silver nitrate is added to 100 ml of 0.01 molar solution of dichlorotetraquachromium 3 chloride. The number of moles of AgCl precipitated would be. So, this question is come from your coordination chemistry of your class 12 NCERT. Now, we are moving to the solution part. Maybe this question is come from a coordination chemistry, but you can solve it with the help of your basic knowledge of your chemistry, that is the mole concept. Okay. They ask you the number of moles. So, number of moles is equal to molarity into V in liter. Okay. Now, if I am converted into like ml, so what is the m into V ml divided by 1000, right. we already know, like see this is the molarity formula, right. N is equal to number W into 1000 divided by molecular weight of that compound into VmL. So, this is nothing but this is moles only, okay. N into 1000 divided by VmL. Now, you have to like do the cross playing here, N is equal to M into VmL divided by 1000. So, this way this formula will come. Okay. Now, see the molarity value, what is the given as molarity, that is given as 0.01. So, 0.01 into, if you see the VmL, how much ml they are giving, 100 ml. So, 100 divided by 1000. Now, do the calculation here, 2, this one will be getting out. So, you are end up with 0.001, see 0.01 divided by 10, it is nothing but 0.001. So, this is the answer. Now, if you see your option, option number 1 is the correct answer, which is 0.001 of your question number 70. So, now we are moving to another question, that is question number 71. So, question number 71 is on your screen. Which of these is least likely to act as a Lewis base? So, now we are moving to the solution part. See, they asked about the least basic, okay, least Lewis base, which is low in basic character, okay. I am writing here in a very easiest way, low in basic character. Now, basic characters are those who can donate electrons, right. Lewis base means which easily donate, okay, easily donate. But here if we see, we have to find it out those compound which does not donate the electrons, okay, who does not have electron to donate itself. Now, if you see the BF3 molecules, this one boron trifluoride, it is an electron deficient molecule, okay. And when electron deficient, they cannot donate electrons. When they cannot donate electrons, they are act as a least Lewis base character, okay. They having a least Lewis base character, that is why option number 3, that is BF3 is the correct answer of your question number 71. They can accept electrons, okay, because they having a vacant orbitals, and this vacant orbitals helps to accept the electrons. That is why they are act as a Lewis acid, okay, instead of Lewis base. So, they in the question they ask you the least basic. So, your option number 3 is the correct answer. Now, we are moving to the next question, that is question number 72. So, question number 72 is on the screen. KMnO4 can be prepared from K2MnO4 as per the reaction. They already given the reaction. The reaction can go to the completion by removing OH ions by adding. So, now we are moving to the solution part. Now, if you see the options, okay, the second option, that is KOH, it's completely eliminate first. Why? Because KOH is dissociate as K plus and your OH minus, means it increase the concentration of OH in the solution. But what they ask here, they are asking by removing of OH, okay, it means we have to decrease the OH concentration. So, this option we can neglect it out. Now, HCl and SO2 we can't use it, because in HCl and SO2, HCl it is oxidized by KMnO4, sorry, your MnO4 it is oxidized to Cl2, whereas SO2 it is oxidized by MnO4 minus to SO3. So, we can't use option number 1 and option number 4. So, we have left it out in option number 3, that is CO2, and this CO2 is cannot oxidize by MnO4 minus. Why? because carbon here it is present in the highest oxidation state, that is in +4 state. So, CO2 we can use to remove this OH minus ion concentration. So, your option number 3 is the correct answer of your question number 72. So, now we are moving to the another question, that is question number 73. So, 73 question number is on your screen. Which of the following is electron deficient? So, now we are moving to the solution part. Now, this is a very simple question, electron deficient, and we all know that is BH3 whole 2. Sometime it will be written as B2H6. So, this is an electron deficient species and it is having a banana bond. Okay, it is a special type of bond which is found in boron complexes, that is banana bond. So, your option number 3, which is a electron deficient species, is the correct answer of your question number 73. So, now we are moving to the another question, that is question number 74. So, question number 74 is on your screen. Structure of the compound whose IUPAC name is 3-ethyl 2-hydroxy 4-methyl hex 3-in 4-enoic acid is. So, this question is come from your GOC part, that is General Organic Chemistry part of your class 11 NCERT. So, now we are moving to the solution part. Now, if you see here 3-in 4-wine means at the third position we having a double bond and the fifth position we having a triple bond, and we have a OH group, that is your carboxylic group. Okay. And for your hydroxy group we have a OH group which is present in the second position, and in the third position we have ethyl group also, that is C2H5 group. Okay. This kind of group we are seen in the third position. Now, in the fourth position we have one methyl group, that is your CH3 group, and how many carbons should be present in the parent set, that is hex, it means 6 carbon is present. Now, if you see the option number 1, 2, 3, 4 and 5, or you can say 1, 2, 3, 4 and 5. So, this is not possible, because if you see they having a ethyl group on the third position. If I am taking from this side also, we do not have any ethyl group on the third position. If I am taking the numbering from this side also, we do not have ethyl group on third position, we have a ethyl group on the fourth position. So, this option we can neglect it out. Now, if you see option number 2, that is 1, 2, 3, 4, 5 and 6. Now, if you see in third position we have a double bond here, okay. In fifth position we have a triple bond here, okay. We have a 6 carbon in the parent set, that is also okay. We have a methyl group in our fourth position, it is also match. We have a ethyl group in our third position, it also match. We have a hydroxy group on the second position. It means the option number 2 is the correct answer of your question number 74.